You know what, I usually don't pick on Alicia right away. So, Alicia, I'm gonna give you a sequence. Here's my sequence. 4, 12, 36. Do you know the next number?
Oh. 108.
108. What did you do to get that 108?
Take 36 times
3. So 3 is what we're going to call R, or what is called the common ratio. How would you determine that 3?
Cut. 4 times 3 is
4 times 3 is 12, and 12 times 3 is 36, correct? You could have done this. You could have taken 12 divided by 4, or 36 divided by 12, and you would have gotten 3 in both of them, correct? So you could take a member of the sequence and divide it by a previous number. Does that make sense to everybody? All right. So, a geometric sequence is one in which the same number is multiplied to each term to get the next term in sequence. The number you multiply is called the common ratio. And we use R to represent that common ratio. All right, so there are a couple of forms that you see how these are work. This is like the initial number, and then it's going to be R to the n. So here, you know, here I have 4, I'm multiplying by 3 of the first, here I'm multiplying by 3 of the second, here I'm multiplying by 3 of the third. So each time I multiply by 3, the exponent will go up by 1. Does that kind of make sense to everybody? All right, good. So another form that you can see it is, the first term is R to the n minus 1. So if I put 1 into here, I would get 0. You'll see me write it like this the most often. And so R to 0 is 1, and so a sub 1 is the first term. There's another way to see it. Sometimes you see it like this. I don't know why anybody would use that way, but sometimes you see it that way. So an example of this form could be 3 halves 2 to the n. So if I put 0 in here, I'd get 3 halves. Or I could have 3 times 2 to the n minus 1. So if I put, if I put 1 in here, I would get 3. If I would put 1, if I would put, 1 in here, I get 3. If I put 1 in here, I would get 3. And then we'll have this, 6 times 2 to the n minus 2. And if I would put 1 in here, I would get 2 to the negative 1 power, which is a half. 6 times a half is 3. So here's another form. I could have 125 times 1/5 to the nth. So if I would put a 1 in here, I would get 25, because I'd have 125 divided by 5. I could have 25 times 1/5 to the n minus 1. And so if I would put 1 in here, I'd get 1. 25 times 1 is 25. And then I could write it this way. 5 times 1/5 the n minus 2. And so this is the general form of a geometric series. You've got your first term. And then you have your first term times your common ratio. And then you're gonna come up with the next term, and you're gonna multiply by your common ratio again. And then you're gonna take and multiply by your common ratio again. So all that happens here is just increases by 1. And I'm gonna write this as a to the r n. Okay, so a geometric series diverges when the absolute value of r is greater than or equal to 1. And if r, the absolute value of r, is less than 1, then it converges. And it converges to this. And this is the formula I always use. A sub 1 over 1 minus r, where a sub 1 is the first term. And r is the common ratio. And the absolute value of r has to be less than 1. And I'm gonna write a sub 1 is the first term of the series. It's been a little bit redundant. So if you take a look here, they start with n equals 0. So if n equals 0, my first term would be what, Sierra? 3. Plus, now if I have n equals 1, what, Sierra, what would be my term? 3/4. And then if I had a third term, what would be my third term? 3 over 16. Plus dot, dot, dot. All right, so my sum, and if you, oh, excuse me, what's my R? Matthew? 1/4. I'm multiplying by 1/4 every time, and that's less than 1, so that has a sum, correct? And that sum is going to be the first number, which is 3, over what, Matthew?
Over 1 minus 1/4.
1 minus 1/4. So that gives me 3 over 3/4, correct? Which is like 3 over 1 times 4 over 3. Would you agree with that?
Yeah.
And so my sum is what?
4.
4. So all this adds up to 4. Okay. The most basic series. So you're going to have a number of tests, and the first thing I look at to see if it's geometric. And if the common ratio is less than 1, the absolute value of it, you know for a fact that it converges. And you can figure out what it converges to by using this. Okay? So let's take a look at this next one. Now sometimes you may have to manipulate it. So I'm going to rewrite this. Notice n equals 2, it's going to infinity, and I'm going to rewrite this as 3 to the first times 3 to the n. So when the bases are the same, you add the exponents, correct? And down here, I have 4 to the n. Now these have the same exponent, correct? So then I can rewrite this as n equals 2 to infinity. I can say I got 3 times 3/4, that's supposed to be a 4, to the n power. Everybody okay with that? So, Jenna, what's our common ratio? So if we start with two, okay, we would have, this would be 9, this would be 16, correct? Because it says you gotta start with 2. I'd multiply that by 3, I'd get 27 over 16. And then, when this becomes 3, I would just take 27 over 16 and multiply it by what? Okay, so let me
1/4.
back. What?
1/4.
Well, not 1/4.
1/16.
Not 1/16,
Right.
but something with the 4. So let me show you the first one. So if I put a 2 in here, I'm gonna have 3 times 3/4 squared, correct? Then, when I put the 3 in there, I'll have 3 times 3/4 to the third, correct? Then when I put the 4 in there, I'll have 3 times 3/4 to the fourth.
So it's just 3/4.
So it's 3/4.
Okay.
Exactly. Okay, which means, Walker, it has a sum, right?
Yep.
Why?
Cause it's less than 1.
Less than 1. All right, Ethan, S equals that sum.
3.
Remember, it's starting at 2 here.
Oh, 2.
Well, what's 3/4 times 3/4?
9/16.
Times 3.
27/16.
So 27/16 is my first term, because it says you gotta start at 2.
Oh,
Are you okay with that?
yeah.
And what am I gonna divide that by?
1 minus 3/4.
Okay. So I'm gonna write 27/16, and I'm gonna multiply the reciprocal. What is 1 minus 3/4?
1/4.
And so I'm gonna multiply by
4.
4 over 1, and that gives me 27/4. Are you okay with that?
Yeah.
I don't know why I circled it, but I did. I haven't told you my growing up story.
Oh, I'm very excited now.
Well, I don't know, it's a math one, it's why, one of the reasons, there are certain things that have happened in my life. Like, when I was in 7th grade, I had the very first time the experience of dreaming about this math problem I was struggling with and coming up with the solution, and I woke up and I wrote it down. I go, wow, that is the coolest thing in the world.
Hey, Kruger, so
But it was really a hard problem.
when n equals 2, that's just what you start,
Yeah, that's your starting spot.
and you go up by 1 every time?
Yep, you always go up by 1, okay? So, even though n equals 2, when I put 2 in there, I call that my first term that I created.
Yeah.
Does that make sense? Okay, great question. Backside. Ooh, this is weird. Does yours look like this?
Yeah.
Yeah.
Okay. All right. So it says, for what value of R does the infinite series equal 23? So that means my sum equals 23, correct? So S equals 23. So that means A over 1 minus R has to equal 23. And N is starting at 0, Grant. So my first term would be what?
17.
17. So A is equal to 17. So now I have 17 over 1 minus R equals 23. Grant, would you agree with that?
Yep.
Tell me what the next step would be, and I'll do it.
Multiply 23 by 1 over 17, or just divide by 17.
Can I do this?
Yep.
Okay, so I did 2 divisions?
Sure.
Okay, excuse me, I did 1 division, 1 multiplication.
Yep.
And so that means R equals 1 minus 17 23rds. Would you agree with that?
Yeah.
So I subtracted this and
Yep.
I added that. So what is R? What's my common ratio?
23rd?
How many 23rds is one?
23.
What's 23 minus 17?
6.
6 23rds. Perfect. All right, so this is kind of a common problem you get, you know, it looks extremely scary. So, this is a calculator active 1, and I'll tell you the steps that I did. I first plugged in 7. And I wrote it down, the summation of n equals 3 to infinity of parentheses sine squared of 7/3 to the n. And so I said, okay, what's my first term? My first term is going to be this with 3 put in it, correct? So I'm going to have, I'm going to use a bracket rather than parentheses. Sine squared of 7/3 raised to the 3rd power. So the way I did that is I found the sine of 7/3 and I squared it, and then I raised it to the 3rd power. So, because I want to do that on my calculator.
0.143.
I did not.
Oh,
Oh,
no.
maybe-
I know the ones.
Oh, excuse me. I am wrong. I was reading the wrong place.
Oh, okay.
Okay, I got 1.42935. What?
You mean .1?
Did I say .1?
You said 1.1.
0.142935. And I stored that in A. You should know how to do that now, right?
Why do you have to write that?
Because we're gonna find what f of 7 is. F of 7 is this, correct? And all I did was put this in the first term. So I know my first term is this,
Okay.
okay?
Oh, that's the first one.
Okay?
Yeah.
What's R gonna be? Not sure? Okay, go back up to this side. Here R was 3/4. Here R was 3/4. Look, I had 3/4 to the nth power, correct? And that was my common ratio, because every single time I'm going to multiply them by 3/4. That's what n allows me to do, correct? So now when I come here, what am I raising to the nth power?
Sine squared of s.
That, right? So what is in that parentheses to the nth power is your common ratio. It's always R to the n. So what is that approximately? I got 0, I'll say it correctly, 5, 5, nope, that's wrong, 5, 2, 2, 8, 5. Is that correct?
I have a question. Are A and A1 the same
Yes,
always?
yes.
Okay.
And the reason I get rid rid of the A1, I don't want everybody to think that N is one. It's always what your first value is. Does that make sense? And so you see me write it just A, and it's just the very, very first term. And so this A right here is the first term. How did we get it? We put 3 in for N. Because it told us to start at 3.
Okay, so the formula on the other side, where it says A times R to the N, what if there was like a constant in front of like the sign, would that be?
Whatever, that's a great question. Whatever the product is when you put your first value of N in there is the very first term. So are you saying that, I'll come up here, let's say you have something that looks like this. And where do you want me to start at?
Just do one. Why not?
Let's say you got a 3 out here, okay? And you got 5 times 1 over N to the nth power, okay? So my first term will be a half times 5 times 3. Okay?
Okay.
And so I would write that A is equal to 15 halves.
Okay, but the formula on the other side makes it look like A would be equal to 5 because R would be 1/2. And then to the nth power, is that not right?
Say it again.
So.
Are we talking about this?
The one to the left.
The one in the-
sigma,
yeah.
yeah.
It's
This
the
right here.
same thing, I think.
Yeah.
It's a different form.
It's just a different form.
But like, the thing that you just wrote,
Yeah.
right? Pretend that the 3 wasn't there.
Okay?
If you would follow that formula, it would be A times R to the N. So with A be 5, R would be 1/2, and then to the N.
Your first term is going to be 5 over 2.
Okay, so it's just plain the first term,
Correct.
no exceptions.
Correct.
Okay, I think I'm good.
Okay. Okay, so back to here. So now we know that the sum, this R right here is less than 1, correct? And it's a common ratio because I'm raising it to a power and it's multiplying repetitively. Are we okay with that? And so what I did is I said, store this in R. You can make it A and B or whatever. I used R because I wanted to keep it in the same form. So then it's going to be, S is going to be A over 1 minus R. And this is where you can approximate the answer that you end up getting. I just gotta make sure everybody can be successful on their calculator to do that. Did you get something that would make me happy?
Yeah.
Like 0.3, if you round it? Okay. All right, so I remember seeing this on the AP exam. When you see something like this, you go, oh my gosh, that looks terrible. And so when they say F of 7, all I did was replace X with 7, right? Because your input is always X. And the thing you have to realize is when you have a constant in here, which this is, raised to the nth power, you automatically have a geometric series because that's what you're going to be multiplying by each time. So you're going to have to know this formula where this is the first term, and then you have 1 minus the common ratio. So this purpose here was saying, okay, we're starting at 3. What is the very first term in my series? That's what that is. Okay? And then you go, okay, what's my common ratio? And that's what we did here, and then you just apply this. Is that making sense to everybody? Okay, so the difficult part is really not the mathematics, it's analyzing it and realizing that they have a geometric series. They love giving you geometric series questions. And you're gonna get a series of tests. The first thing I always do is it a geometric series? Do I have some number in here that I'm raising to the nth power? Okay, and that's the indicator. We doing okay? All right, so I'm in 8th grade, and I had Mr. Schiller as a math teacher, and he showed me this. He says, all right, x is equal to 0.3 repeat. That means if I multiply by 10, and we learned this early, you move the decimal place one place to the right. So now I have 3.3 repeat. So I subtracted, and lo and behold, I get 9 here, x, and I got 3 here, and then I found out that x is equal to 3 over 9, which is 1/3. I thought, okay, I knew that 1/3 was 0.3 repeating. And then he said, well, watch this. Let's say x equals 0.9, oops, I give myself some room. X equals 0.9 repeating. Well, that means 10x would be 9.9 repeating. Subtract. 10x's, take away 1x, 9x, get 9. Divide both sides by 9. 1 and 0.9 repeating are exactly the same number. Oh, wow. Okay. And that was one of the things that got me interested in mathematics, that's even possible, because that didn't make sense to me. Well, the reason it didn't make sense to me is I didn't understand what a limit was, and what this is really is a geometric series. In other words, 0.9 repeating is 0.9 plus 0.09 plus 0.009 plus 0.0009 and so forth, correct? And so I can say, hey, n equals 1 to infinity, and what I'm doing, like, what am I multiplying by every single time? What causes me to move the decimal? 1/10, right? So 1/10 is my common ratio, correct? Okay, so it's geometric just because I did that. Now, if I put 1 in here, I get 0.1, so the number that's out there is 9, correct? Then I can check. And so I can figure out this sum. Down here I have 1 minus 0.1. Are we okay with that? And 0.9 is my first term. I showed it to you, correct? Okay, now I am now a freshman at Bemidji State, and we're talking about infinite series in the fall of 1976 in my accelerated pre-calculus class. And Dr. Knoll showed me this, and he says, well, guess what? That's 0.9 over 0.9, it's 1. Oh, that's really good. So here's an algebraic form, here's a geometric series form. Okay? So, I taught at a district called Eden Valley Watkins, and my last year there was 1998, and I had a 7th grader in class. And he says, well, 2/3 is 0.6 repeating. No one would disagree with that. 1/3 is equal to 0.3 repeating. No one disagrees with that. Add them together, so 1/2 equal 0.9 repeating. That guy now works for St. John's and St. Ben's, somewhere in the business office, and makes St. John's and St. Ben's a lot of money. So at the time, I was going to my master's degree, and I was taking a class called discrete mathematics. And I thought it was a class where we quietly talked about mathematics, because we did it discretely, so we didn't want people to know what we were learning. What it was a proof class, and I did 40 proofs every single day, which took me about 8 hours. And so we had done a proof on this, and then I showed him Ben Stummis's proof, and the professor was totally blown away. So this has been kind of a recurring theme, this whole idea that 1 is the same as 0.9 repeating. And you can do this with any repeating decimal. If I say, okay, I get 0.16. Well, 0.16 is my first number, then I'd have to have 0.0016, correct? So that means A would be 0.16. What's my R? What allows me to move the decimal 2 places as well? Yeah, 0.01, right? So that means I'm gonna have 0.16 over 1 minus 0.01, which is 0.16 over 0.99, correct? The sum is 16 over 99. Does that kind of make sense to everything? So, that's geometric series, and again, just look for what is being raised to the power. And so